You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more conversations and articles, please visit thenewstack.io. Now on with the show.
Couchbase delivers a high-performance, flexible, and scalable modern database that runs across the data center and any cloud. Many of the world's largest enterprises rely on Couchbase to power the core applications their businesses depend on.
Hi, and welcome to another episode of the New Stack Makers podcast. I'm your host, Heather Joslin, features editor of the New Stack, and today we're going to be talking about the Edge, Internet of Things, or IoT to its friends, and dealing with data in those environments. Our guest today to help us explore this topic is Mark Gamble. Mark is Product and Solutions Marketing Director at Couchbase. Hi, Mark.
Hey, Heather.
Mark, can you tell us a little bit about Couchbase and what it does?
Yeah. First, thanks for having me, to you and the New Stack. I'm really excited to be here. And Couchbase is a cloud-native NoSQL database technology that's used to power really gigantic applications like those for our customers at LinkedIn and Tesco and Comcast, Amadeus, and more big enterprises who use us to power their really critical applications. And I like to describe Couchbase as sort of this combination of NoSQL database concepts. So first, it's the processing of key value information in memory for hyper-fast responsiveness. This is how a lot of websites stay lightning fast, for example. And then second, the distributed storage of JSON-based documents, document-based data in a schemaless nature for, flexibility because it's JSON, and then resilience because it's a distributed architecture. And then to this, you add full support for containerization, mobile and edge capabilities, which we'll talk more about today. And a full set of built-in features like SQL query support, something you don't usually find with a NoSQL database, and full-text search, eventing, analytics. It's really a multi-model database. And these are things that our customers, also no longer have to bolt together from a bunch of different technologies. It's all part and parcel. And sort of with all of this, you have Couchbase in a nutshell. And Couchbase Capella, I have to mention, is our flagship enterprise class database as a service. So it provides all those features I just talked about of Couchbase, but fully hosted and managed in the cloud. So that's sort of Couchbase in a nutshell.
Okay, terrific. And we'll talk a little bit more about Capella a little later in the conversation. But there's a lot to talk about, so let's just dive right in.
Cool.
If you're working for an enterprise, what are some of the most common use cases for which you might be running workloads at the edge or through an IoT device?
Sure. Typically when I'm asked these kind of questions, I like to sort of define what edge computing means to me or us.
Okay, well let's back up
from
and do that.
And from the database, and that leads into the question for sure. But so the essential goal of edge computing is really to bring data and compute closer to the applications that consume it. In other words, put the database nearer to where the data happens, including on the device itself. And this makes apps go faster because, data doesn't have to travel all the way to the cloud and back. Very simple concept. But this serves to make, applications more reliable because local data processing sort of removes internet slowness and outages from the equation. And there's sort of this spectrum when it comes to edge architectures. And, on one side, there's a standalone edge device, where the database is embedded to the applications that run on the device. And so you're talking the usual cast of characters here, right? Smartphones, tablets, scanners, IoT devices, these common devices that are typically used at the edge. And, we've all seen the overnight delivery driver, the custom ruggedized tablet scanning packages in the back of that delivery van. That's kind of a perfect example of an edge device. And then sort of on the other edge of the spectrum, if you will, you have edge data centers. And by that, I don't mean a gigantic, cold room. It could be an IT closet in a restaurant or a server rack on a cruise ship or in a warehouse or big box retail store. And these, local mini data centers, if you will power apps and IoT devices within their local radius. And where an app falls in this spectrum sort of depends on the scale and downstream clients that it has to serve. But in these cases, both sides of the spectrum, it's all about bringing that data closer to the application or clients that use it.
My understanding too is of edge computing is sometimes it's also not just to have the data be stored or analyzed where it is, but also some jurisdictions have rules about where data can live.
So data residency and sovereignty and these kinds of things. International businesses know GDPR. Edge computing is a great enabler of kind of, better data governance because, yes, you can do things like keep data where regulations dictate. If you're a hospital, you can keep data in the data center on premises. Sensitive data never has to leave the edge. And so you're spot on. That data governance is another clear benefit of edge computing.
Right.
Yeah. And you asked originally about use cases, and that's actually where it starts to kind of illustrate these concepts. So the use cases are really vast that we're seeing at Couchbase. Wherever there's the need for accessing data more quickly and efficiently, or governing that data, better at the source, edge computing can help. So consider like an offshore oil rig at sea. A typical platform can produce terabytes of data every day from sensors and devices all over the place. And, monitoring and analyzing that data is really the only way to run the platform efficiently. But the data just, comes so fast and there's so much of it that it's impossible for operators to monitor and analyze it all, especially in real time.
Yeah.
And so they compensate by slowing down operations and, add to that the need to also operate in remote locations like the North Sea. Right, where reliable internet's really scarce, and when it is available, it's usually via satellite, and it's just slow and costly. And so now imagine, an IoT sensor, a pressure valve, let's say on the platform, that sends readings to be analyzed in the cloud. If you're using a cloud model, to detect possible problems or failure, and it takes time, right, for the data to go upstream, get processed, get a result, come back down the wire, and by the time you get that result, the valve might have failed. And, if the internet isn't available at all, the app just can't analyze data at all. So that's downtime. And that's, it can lead to downtime or worse. So, edge computing solves for this by putting the database on the platform, for example, and even onto the apps running on the IoT devices and on operators, smartphones and laptops. And in this way, data is synchronized locally. You create this sort of local ecosystem, if you will, and analyzed locally. No long wait, no internet outages to deal with, and the apps work reliably, without internet. And so that's one, I think, illustrative use case. But, we see this used in point of sale applications in retail. So by leveraging a local data center, retail outlets can continue to service customers even if the network fails. It's, again, super simple concept with huge implications. Business downtime hurts sales, but it also hurts reputation.
Yeah.
And people tend to air grievances these days about poor experience on social media. So keeping business running I know it never happens, right? But that's one of the reasons that our customers come to us, because they know, keeping business running, that applications available, is how you keep customers happy and try and eliminate downtime. So, move that data processing to the edge. Retailers can eliminate those dependencies on the cloud and internet and get better guarantees of uptime. And so we see, I mentioned hospitals, manufacturing's another one, the cruise industry, kind of circling back around. I'll sort of end this answer with this, because I think it's another great use case. Ships can use onboard data centers instead of cloud data centers for passenger services. And one of our customers is Carnival Cruise Lines, and they run an edge data center on their ships to power their Ocean Medallion application, which they're super proud of. They use it in a lot of their ads because it provides this personalized service, which is a differentiator for them, to their customers. It's an IoT device that every passenger wears, and it lets them into their room and lets them change, when they move from the bar to their dinner table and to the pool, their drink will follow them. And, they can buy amenities anytime without touching anything. And it works even when not connected to the internet. So, these are just sort of some of the kinds of edge use cases that we're seeing our customers adopt and implement.
Obviously, mobile devices are a big user of edge computing, as we mentioned, and mobile providers are rolling out 5G networks all over the world. Where does 5G fit into all of the story of edge computing? And
Sure. Yeah. So 5G is super hot. It's like when my grandma even knows she started saying, "Oh, it's 5G." I'm like, okay, it's more than a buzzword. It's out there if my grandma even knows about it. So, but there's good reason for the hype, right? It's, to compare with 4G, things like the average round trip data travel time between a device and the cell tower is like 15 milliseconds. And with 5G, that latency drops to like 2 milliseconds. And 5G can support, they say, 1 million devices within a third of a mile radius, way more than what's possible with 4G. And it boasts, multi gigs per second data transfer, just mind-boggling, blazing speed. And that leads some to ask, well, that's super fast. Why do you need edge computing to speed things up? And the benefits of 5G, it needs to be clear, are really, they apply to the last hop, right? The radius from the tower, that distance from the cell tower to the device. Everything within that radius is super fast. But then the round trip from the tower to a cloud data center and back can still take up to 500 milliseconds or more, depending, really on where you are. So this means that apps that use a cloud database still rely on internet to operate, even on a 5G network. And a speedier kind of final hop can't make up for overall internet latency or outages. And so kind of my lead in there is to get the full benefits of 5G. I think you need to bring the processing of data, within the 5G radius. Or, I think 5G really requires edge computing to realize its full potential.
We talked a little bit about the apps that are the need for data processing and storage when internet is spotty or non-existent. My understanding is that Couchbase has been hearing more from customers about looking for offline first applications and the data needs involved. What does Couchbase do to address these issues involved in offline first apps?
Yeah, offline first is, 2 years ago I heard the term and I was like, huh? You can sort of guess what it means, but now we're hearing it more and more. But the thing is, our customers don't come to us and ask for offline first. They come to us with specific problems that are always, related to network connectivity and their app's reliance on it and its risk of failure. So we're seeing more and more of these, offline first app requirements. And it's really a class of edge application. Where the app has to operate in areas of no internet for kind of extended periods of time. We're not talking, going through a short tunnel or a few subway stops. I mean, I'm talking where there's no internet at all for hours or days or longer. So places like underground in a mine or in deep in remote wilderness or driving through the middle of Iowa or on the world's longest flight, right? Emirates just announced Dubai to Panama City, 17 hours. These are places where internet isn't typically available, but there's still, a strong need for work to be done and goods to be sold and customers to service. So kind of this defining characteristic of offline first apps is working in isolation with a need for the apps to work even when completely disconnected. And so some examples would be like insurance agents, making claims adjustments in the field. They need to sell and update policy information, in disaster areas, maybe where there's little or no network connectivity. Another example is inspectors at utility companies that perform maintenance activities. They work on equipment and conduct repairs. They need access to task lists and historic inspection results and infrastructure maps, but they sometimes need it, working out in the middle of nowhere, on some wind turbine. But then, it doesn't only mean remote. It can also be in the middle of a major metropolitan area. Your restaurants, they want to streamline meal ordering, and drive-through order experience for their customers. And in many cases, they're extending that service out to the parking lot or the curbside.
Yeah.
Taking adjust orders from mobile devices. How many places do we pull into? Not that I eat fast food, but when I pass a fast food restaurant, it's starting to become more common where you'll see that instead of just a box you're talking to, there's a person holding a tablet, and they walk down the line and they're taking orders. And as they come, closer to the restaurant, syncs up with the kitchen, they find that just a better, more efficient way to serve customers. And so it becomes a, competitive differentiator for them. And mobile clinics are another example of offline first. These are real customer examples I'm talking about. But, healthcare workers in remote rural locations can pull up, patient medical history and update prescriptions and things like that, even when there's no connectivity available. Couchbase provides this developer-friendly mobile database, and it has synchronization built in. So not only is local data processing, but it can share that data across this app ecosystem. And it serves these types of use cases perfectly. Our customers, use our database to build offline first apps that are impervious, if you will, to internet slowness or outages. And sort of to help illustrate that, another customer tale, if you will. And I just think they're so evocative of what it is. So Backpack EMR is one of our customers, and they provide apps for mobile clinics in remote and underserved areas where there's little to no internet. Yeah. And we're talking villages in Haiti, these kinds of things. And they embed Couchbase to the apps that run on tablets. And this allows them, of course, to operate in a completely disconnected mode. But they also leverage built-in peer-to-peer synchronization so that they create this little mini clinic where nobody, people are walking around with a database in their hand, but it's also sharing with everyone. And so clinicians, get access to patient histories updated in real time. It's shared across the clinic. And they can instantly and securely, share that from registration to vitals to labs and exam rooms. Even through to the pharmacy. And this kind of ability to work in isolation, but still collaborate, I think it's a unique feature to Couchbase, but so, illustrative, I guess, of that offline first capability. They can set up a mini hospital, and it doesn't matter that they're in the middle of the desert. It's going to work, and so sort of leveraging Couchbase to ensure that works everywhere all the time nature. I'm proud of Backpack EMR as a customer. I think they're really helping provide vital healthcare for areas of the world that need it.
Yeah, it sounds like it could be potentially life-saving too. I mean, to people.
Indeed.
Can you tell me a little bit about Capella? What is Capella, and what's new in that area?
Sure. So Couchbase Capella is our database as a service. So when I talked about Couchbase, et al., if you will, it's Capella is all of that as a fully hosted and managed service. And so what that does, it allows our customers to adopt Couchbase, adopt NoSQL really quickly. They don't have to procure hardware and install it. And it's just out there as a service that they sign up for and off and running. So it becomes this, boon to developer productivity. They, don't have to manage infrastructure on the database side anymore. And we recently are excited to announce, introduce Capella App Services. So this works in tandem with, the database as a service. It's a really popular new capability, for mobile developers. And App Services provides this fully managed backend designed for mobile IoT and edge applications. And, developers use it to access and sync data between the database as a service and their edge devices, as well as it handles authenticating and managing mobile and edge app users. So, sort of talking about the Couchbase mobile stack, it's made up of three pieces. Couchbase Capella is really the, kind of bedrock that, fully managed cloud NoSQL database as a service. And then Capella App Services I just talked to, that's the fully managed service for backend bidirectional sync. And it handles authentication and access control. And then Couchbase Lite, which I don't think I've mentioned yet, but this is the database. It's Couchbase that is meant to be embedded. So it's lightweight. embedded NoSQL database that our customers embed to their, mobile apps and IoT devices. Mm-hmm. And Capella App Services is really arguably the sort of binding ingredient in the mix here, so, synchronizing the data between the backend database and edge devices, and providing sort of this key component of partition tolerance, getting into the CAP theorem a little bit of edge computing. So without app services, data changes are shared across the app ecosystem. And I talked about you can work in isolation, but eventually you have to make sure that data updates are shared with the rest of the ecosystem. And that's what app services is meant to do as connectivity allows. So, during network disruptions in areas with no internet, apps will still continue to operate thanks to that embedded database. So, app services is included with the Capella free trial. So I really want to, encourage your listeners to check it out, try it for yourself. Just go to cloud.couchbase.com and hit the sign up button, and you'll be, working with the database in minutes. It's really impressive how quickly it works.
Looking ahead, what do you think are some of the biggest problems that still need to be solved regarding data in edge IoT environments?
Sure. My answer, once might have been complexity, right? Mm-hmm. It takes careful planning and some know-how to adopt an edge architecture. But, as edge computing has caught on, a technology like Couchbase has become available, it's getting easier. Mm-hmm. But as our customers who build these offline first apps we were talking about know, network connectivity is a constant challenge. So maybe I'll go with, networks as the yet to fully solve issue with edge, and the network really remains a big potential point of failure for any edge architecture. It's integral, mm-hmm. but it's also that point of failure. And it's because all networks, suffer from issues at some point. Signal degradation, line condition, mechanical failure, cloud cover, mm-hmm. temperature. Yeah. These can all affect network speed and availability, and all networks have these issues, whether they're wired or wireless or 5G or satellite or Bluetooth, et cetera. Even if one goes faster than the other, none is, totally immune to being slow or failing outright. Mm-hmm. But one might posit, how does this affect an edge device with its own local data processing? Well, it's back to, when it comes to sharing that data. Mm-hmm. In a multi-user application where data changes rapidly, local changes have to be synced to the rest of the app ecosystem. And so sync has to happen in spite of these network issues. Mm-hmm. And at Couchbase, we've always tried to, we feel we've always understood this imperfect nature of networks, and we've provided the means for developers to work around these issues by making sync automatic, and making sure that it can take advantage of any connectivity, no matter how brief, and also making sync super efficient, mm-hmm. with things like compression and delta sync, only sync what's changed, not more. Features that minimize data sent over the wire when you do have that precious connectivity. So mm-hmm. that's these are efficiencies I think we bring to the table that kind of help with those problems. But networks, are probably always going to be a challenge with edge.
And finally, can you point to any new developments emerging in the field that you would advise listeners who are concerned about running data on the edge to pay attention to?
Sure. Yeah, I think one big development is, I mentioned it earlier, alluded to it. It's becoming easier for an organization to adopt. It kind of used to be the hallowed halls of the ivory tower, the biggest companies with the biggest IT departments were the only ones who could do this because you had to build it all yourself, mm-hmm. right? The fact is, even the simplest edge architecture can be extremely complex, especially as the number of edge clients that it has to serve, increase. Mm-hmm. And it used to be that organizations had to adopt edge computing by setting up and managing their own data centers and procuring hardware and infrastructure and install and integrate all the software, knit all the pieces together by themselves. And that's kind of daunting for the inexperienced. Mm-hmm. But over the past 2 years or so, cloud service providers have begun rolling out edge services, literally cloud infrastructure that customers can deploy to a local metro data center or onto a 5G network or even on their own premises. Mm-hmm. So you probably heard of services like AWS Local Zone,
Yeah.
AWS Wavelength, AWS Outpost. Azure has its services as well. Azure Public Mech, Google Cloud, GCP Anthos, and Extended Cloud. These are emerging services that are making edge computing less complex, so that anybody with AWS, Azure, GCP expertise can, construct an edge computing environment for their own applications. And Couchbase is partnering with all of these cloud service providers. And, that I mentioned, we've done latency tests with AWS Wavelength, AWS Local Zones, and Azure Public Mech. And they prove out what we've sort of been saying and what the claims are. That over an 80% reduction in latency for applications when you leverage Couchbase in these environments. And we've been certified as service ready for AWS Outposts. We have more tests underway, in fact, for AWS Snowcone, which is their appliance. It's AWS in a box that you can literally put anywhere.
Oh, wow.
And we're doing that with Starlink, low Earth orbit satellite. And just to test, okay, are these claims of ultra low latency true? And we always find out that they are, but it's just really validating that, the promises of edge computing are there, combine data processing with these edge services, and you can realize it a lot easier than you may have thought. I'd like to encourage folks to look into those emerging services and of course, Couchbase to help get around, any of those, the challenges they might be assuming are there.
Okay. Well, I think thank you very much, Mark, for joining us today. That's a wrap for this episode of Makers. Again, thank you, Mark Gamble of Couchbase, our guest for this conversation about data and the edge. And we'd like to thank Couchbase for sponsoring today's episode of the podcast. I'm Heather Joslin of the New Stack, and I've been your host for today's Makers. Thank you all for joining us, and we'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.